10.2, circumference and arc length. Just a quick video over the notes I already took. My stylus broke, so I'm going to have to use my finger. So I'm using the notes that are already there. I'll just kind of highlight what I did and why. All right, that said, what is pi? Pi is the definition of pi is the circumference divided by the diameter. And no matter what circle you use, it'll always be right at 3.14159. It goes on forever because pi is irrational. Circumference, that is the distance around a circle. All right, so it's equal to 2 times pi times r, or you'll hear me say 2 pi r most often. That is circumference. All right, in example 1 here, it says find the circumference of a circle with radius of 6 centimeters. And before we get started, notice it says keep your answers in terms of pi. That just means that pi is going to show up in the answer, and you'll see that circled a lot of times in my answer. So for example, number 1, here I took my general equation, c equals 2 pi r, that's from the last slide, and instead of r, I replaced it with the 6 right here, okay? And that gives me 2 times 6, which is 12 pi, and again, you leave pi in your answer, because pi really is just a number, so 12 pi is saying like 12 times pi. Same thing for number 2. Again, start with the original c equals 2 pi r. That's the given equation of circumference. And instead of r, I'm going to put in 2 square roots of 3. And 2 times 2 square roots of 3, I'm multiplying these two together. That gives me 4 square roots of 3 pi inches. Number 3, same thing, except now we have a radius of 1.5 centimeters. So again, I replace the r with 1.5 right here, and 1.5 times 2 is 3, so 3 pi inches is the circumference. Next slide says find the radius of a circle with a circumference of 31 pi. So again, we're going to use our c equals 2 pi r. And I also want to say that c equals 31 pi, because that's what our directions tell us up here. So let me get rid of those. And since c equals both those things, I'm just going to set this part equal to this part in this equation over here. And so I have 2 pi r equals 31 pi. Trying to find what r is, it says find the radius. So I divide the left side by 2 pi. Those are going to cancel. Over here, the pi's cancel. You're left with 31 divided by 2, which is 15.5 meters is the radius. Number 5 is very similar. Again, the original equation, c equals 2 pi r. The one that they give us in the directions is circumference of 10 pi. So again, set those two equal to each other. And 2 pi r equals 10 pi. Again, the 2 pi's will cancel. You're left with the radius, which is what you want. 10 divided by 2 is 5, so this gives you a radius of 5 meters. Number 6, find the radius of a circle with a circumference of 94.2 centimeters. Same thing, c equals 2 pi r, and c also equals 94.2. Notice this 94.2 does not have a pi in it. The other two that we did on this page do have pi. This one does not, and that'll show up here when we do some division. So again, set those equal to each other because they both equal c, so you can do that. And when I set them equal right here, I have my 2 pi's that cancel on the left side, leaving me with just r, which is good. On the other side, 94.2 divided by 2, I can get 47.1, but notice this pi has nothing to cancel with, so it stays on the bottom down here. So your answer actually has pi in it on the bottom, 47.1 divided by pi centimeters. Excuse me. All right, next one, measure versus length. Measure refers to the degree of an arc, right? And length refers to the portion of the circumference. Notice I drew a little picture right here, two kind of a smaller and a larger circle, where this note says 2 arcs can be the same length or same measure, but have different lengths. All right, so here I took just kind of a quarter of that circle. That's a 90-degree angle. And obviously the one on the left is a lot smaller for that red section than the one on the right. All right, we have arc length over C circumference is going to equal arc measure over 360. And I circled this where it says, in other words, is we have the part of the whole for the length equals the part over the whole for the degrees. All right, we're going to use that for the rest of the slides. All right, number one, for the arc length says, I first wanted to find just what the circumference was, so I took my C equals 2 pi r from our first part of our notes, and I inserted 8 for the radius. 2 times 8 is 16, so circumference is 16 pi. And then this portion right here, that's the same thing as they gave us. It's actually also kind of over here in that dotted square. That's our formula we're going to use. So we don't know the arc length. We want to find the length of AB right here in our circle. So I'm going to call that X in the next line down, right there. And if I put that over C, the circumference that we found earlier, then I get X over 16 equals 60 over 360. The arc measure 60 over the 360 for all of that. Okay, now I know that 60 over 360 equals 1 over 6, right? And you can probably see that too. The zeros cancel. 6 divided by 36 is, if you divide each by 6, you get 1. 36 divided by 6 is 6. Cross multiply, since it's a proportion. 6 times x is 6x. That's coming down this next line right here. 6x. And then 16 pi times 1, if you cross multiply those, you get 16 pi. So that leaves me with 6x equals 16 pi. Divide each by 6 to get what x is. That's going to be the arc length. And we get 8 pi over 3. Okay, just if you simplify that. So remember your label. This is in centimeters. So 8 pi over 3 centimeters is the length of AB. Very similar for number 2. Number 2, again, I find the circumference by using the radius of 11 centimeters. So if I put that into the circumference formula, 2 pi r, you get 22 pi. This next part that I'm putting a box around is our arc length formula. So again, we don't know the length of EF. That's what we're looking to find right here. So we're going to say that's X over 22 pi, our circumference, C, equals, again, 60 over 360. Just like the last one, 60 over 360 is 1/6. So if I cross multiply this proportion, I'm left with 6x equals 22 pi, divide each by 6, and x equals 11 pi over 3. All right, arc length, again, same idea. I think it's actually the same problems, just different numbers. So again, find the circumference to start with. They give us 11 again for this radius. So I'm going to put that in for r. Circumference is 22 pi. Again, you can see the arrow that I drew right here. We're going to use that formula. So again, I don't know the arc length. I'm going to call x over 22 pi, what I just found for the circumference, equals, now it's 120 over 360. If you divide each of those by 120, you get 1 over 3. So again, set up a proportion. 3 times x is 3x. 22 pi times 1 is 22 pi. So we get 3x equals 22 pi. Divide each by 3 to get what x is by itself. 22 pi over 3. And that does not simplify anymore. So that is our answer. You can see down there on the blank. Number 4, same idea. C equals 10 pi this time when you put it in for the radius. I did not write out the formula, I just stuck it in. So x over 10 pi equals 50 over 360. This one does not simplify as nice, but it does a little bit. The zeros cancel if you divide each by 10. That's what I mean when I say zeros cancel. And you're left with 5 over 36 for that side. Cross multiply to get 36x equals 50 pi. Divide by 36. Again, doesn't simplify the best, but it does give you 25 pi over 18 centimeters. Number 5 says, let's see, we have this time, same idea, we're looking for CD. So that's this arc length. Oh, a little wonky there. We end up with x over 14 pi equals 100 over 360. That's for our arc length formula. 100 over 360, you can divide each of those, I think by, what is it, 20? And I think you get 5 over 18. So we get 18x equals 70 pi if you cross multiply this next one. And that's going to leave you with 18x equals 70 pi. Divide each by 18, so x equals 35 pi over 9 for that arc length. Number 6 is a little bit different. It gives you the arc length of 3.82, and on this one, it wants you to find the circumference. Okay. Now this one tripped me up a little bit because I thought that our answer needed to be in terms of pi like that other one, but notice the directions on this doesn't say anything about that, so we can leave it as just a decimal. Okay, I want to use the same formula I've been using. So I have 3.82, this arc length, now we do know it, over c. C is going to be our unknown now on the bottom of our fraction. All right. So that equals 60 over 360, which if you remember from number 1 and 2, that's going to be 1 over 6. All right. So we have 3.82 over c equals 1 over 6. Cross multiply. And when you do that, 3.82 times 6 is 22.92. And c times 1 is just c, which is what we want. We want just a circumference, c. So 22.92, don't forget your label, meters, is the answer to that problem. All right, one left. This one, number 7. We do want to find the arc length this time of, or not the arc length, we want to find the measure, excuse me. So we're looking for how many degrees you could say this is, or since that's a central angle, you can say how many degrees that is as well. They should be the same. Let's see if we can get 135 like our answer says. Again, what circumference? I'm taking c times 2 pi r. The radius on this one isn't very nice. It's 7.64. So 2 times 7.64 is 15.82 pi. Again, I'm going to leave pi in there. So using, let's see, in this formula right here, it's the same as that one. I'm going to fill in the parts I know. I know the arc length is 18. I know the circumference is 15.28. What I don't know on this one is the measure. I don't know how many degrees it is over the total 360. All right, the bottom one is always, bottom right one is always going to be 360. So if we cross multiply, 18 times 360 is 6,480, and that's going to equal 15.28 pi times x. And again, I want to find x here. I'm trying to get the x by itself, so I need to divide all the rest of it by 15.28 pi. And we divide 6480 divided by 15.28 pi. You get 134.99, which is close enough. I just rounded up to 135 degrees. All right, and that's all the notes I have for you for this section.